Today, we're going to look at hydrogen, possible fuel source of the future. We'll kind of see. We're going to take a look at two different ways we can do it and see what we can see. So, when we talk about hydrogen or extracting hydrogen, because we don't find it anywhere on the planet, very common, but it's trapped in water, chemicals, living things, etc. So even though hydrogen is incredibly common, it's negative net energy. Let's take a look at one of the easiest ways we can actually extract hydrogen. It's called electrolysis. And we take electricity. In this case, I'm just going to take a 9-volt battery and we're going to drop the terminals down into the water. And we'll start generating oxygen on this one, which in this case is iron, and hydrogen off of this terminal, which is copper. So I'm going to drop them in and then come in a little closer and let you see what's going on. So once again, we can see the bubbles being given off, but once again, let me bring you in real close. We'll take a look. So here, you can really get a close-up look at that process. Hydrogen being given off. Very, very simple, easy to do, but unfortunately it's expensive. So hydrogen winds up being a negative net energy. So, even though this process works, it has its downsides. Once again, it's expensive. I can't afford to do batteries to get the amount of hydrogen we get off of it. And along the way, everything winds up getting corroded. You can see the water is already starting to get kind of a brownish yellowy color. If I lift this out, it's corroding off on the iron. So although the process works, it's got all sorts of issues. A lot of them are overcomable, but it's the sheer cost of electricity that doesn't make this viable as of now. We'll take a look at another way we can do it through chemical reactions. Now, another way we can extract hydrogen is through a chemical reaction. I've got concentrated hydrochloric acid and aluminum powder. Now we could put aluminum foil, a chunk of aluminum, anything. Powder just works a little quicker. You want to be careful with this, so kind of gloves for it. Pretty concentrated. Here, got the acid done. I need to get a balloon on it to capture my hydrogen. So aluminum goes in and we're going to get a chemical reaction. So hydrochloric acid plus aluminum will yield aluminum chloride and hydrogen. In this case, I'm after the hydrogen. Aluminum chloride is used in some business, manufacturing, etc. I'm going to step back in case my balloon pops. And it looks like our balloon's going to withstand the heat and the pressure. Now this is an exothermic reaction, so this whole thing gets pretty hot, and every now and again if the balloon's got a weakness, it may pop and fail. But here we go. So at this point, I have my hydrogen trapped. Get my gloves back on once again because it's hot to try and handle it. We're going to pop it off of there. Then we can ignite the balloon. We'll come over here and take a look at that in just a second. And here we have the hydrogen in the balloon, so we'll see what happens when we put it to a flame. There we go. Pretty explosive stuff, right? Hydrogen. And there you go, extraction of hydrogen by hydrolysis and a chemical reaction. we wind up getting hydrogen, as we've seen, a very combustible or flammable material, great for a possible fuel use. We'll just see if we can find a way to extract it more cost affordable. There you go. See you guys.